Example 1.17 part B has a different equation to look at. G of x equals the square root of x plus 2. And if I start playing with some of the values, we might plug in something like 0. G of 0 gives us the square root of 0 plus 2, which will be the square root of 2. And the square root of 2 is approximately 1.4, and ultimately what's important here is that it's a real number. So when we're looking for things that are going to be a part of the domain of an equation for a function, we're looking for things that are going to always map to real numbers. So 0 seems like it's going to be okay. So let me draw a number line for us to be able to keep track of the values that we've come up with, and we say 0 is going to be good. So we'll put a point there at 0, and we'll try some other values. Say we try 1. That'll be the square root of 1 plus 2, which is the square root of 3, and that is approximately 1.7, which means that it is also a real number. So that means 1 is also going to be okay. But if I start going into the negatives, I might find that there's a bit of a problem. So, for example, if I was to substitute in negative 3, that would give me the square root of negative 3 plus 2, which is going to give me the square root of negative 1. And the square root, by definition, requires us to take the square root of positive values, or we could even take the square root of 0. But this is neither of those. It's not 0, nor is it positive. It's negative. So this is not an element from the real numbers. So therefore, negative 3 does not get to be included in this. Well, same thing would be true for negative 4. Substitute in negative 4, and I end up with the square root of negative 2, which is going to have the same issue. This is now not going to be representative of a real number. So in example 1.17a, we found that there is exactly one value that was not going to work with that particular equation. But in this situation, it seems that we have multiple values that are not going to work, because we've already found 2. In fact, there's going to be a lot more values that are not going to work. So there is an algebraic way for us to determine exactly which values will be okay and to determine which ones are not okay. So if I take the expression x plus 2, which is the expression that is underneath the radical, I should be able to take that and set it to be greater than or equal to 0, because that's what the square root by definition allows. It allows anything positive or anything that is 0, or if it's equal to 0, to be underneath the radical there. So by setting up this relationship, I can then subtract 2 from both sides to get that x has to be greater than or equal to negative 2. So going to my number line, there's negative 1, there's negative 2. This inequality says equal to negative 2, as well as everything that is greater than negative 2. So it would look like this. So the domain, we'll write the domain above the number line here. The domain of G is going to be equal to, close bracket, negative 2 to infinity. That represents the red line we have here on the number line. So that's one part of this. That's our domain. And then we need to define the function. So our function name is G. The domain will be used as the first set, and we will always be using the real numbers as our second set. So regardless of whether we use all of the real numbers in the second set, we still want to have that there to represent that the domain is always the values that map to other real numbers, and this is going to be given by the equation g of x is equal to the square root of x plus 2. And that becomes the function definition.